Hello, welcome to another VSG expanded video. In today's video, we're going to be speaking about SD branch, more specifically the physical topologies of the branch and some of the logical things within the branch as well. So if it's L2, L3, redundant, non-redundant, we're going to be speaking about the different things you should consider depending on how you deploy an SD branch site. But before we even do that, I want to make sure that we're on the same page when it comes to what a branch is. Now, generally at Aruba, we define a branch as a remote site that doesn't have local applications. Now, that doesn't mean that's a one size fits all. There's tons of branch sites that have applications on site, but in general, that's how we define a branch site. So now that we both understand what a branch site is, let's talk about what the physical deployment can look like and the different things to consider within an SD branch deployment. On screen here, we have the first branch deployment site that we're going to be speaking about. It's a non-redundant branch with a single gateway. Let's drop the WAN side. We're not really going to be focusing on it, but just for the sake of completion, we're going to probably have two uplinks. One will be internet, one will be MPLS, and then it'll connect over to a head-end or hub site, and then it'll have the compute behind that hub site. And this compute would be Active Directory server, AAA like Radius, TACACS, maybe your DNS server, all that type of stuff would be hosted over here. Moving back over to the branch, let's kind of get our bearings. So we have three subnets. We have a management VLAN, a user VLAN, and another user VLAN. So we have three VLANs total. And these are going to be trunked to our gateways and to our switches. And then we're just going to pass down that management VLAN to our APs. So that's kind of the LAN side of the branch. So it's just L2, pretty simple. Now let's focus on some of the design considerations in regards to this branch deployment. So the first thing I want to talk about is the system IP address up here. This is the management IP address for the gateway, but it's also used as the source interface for things like Radius, TACACS, DNS, DHCP, those types of services, as well as tunnel termination. Your switches down here and your APs, when they do their tunneling, you're going to be tunneling to this system IP address. So it's important that it's reachable. There's a couple of ways that it gets configured. The first way we'll talk about is the system gateway pool. This will be a subnet that you designate. And then from that /16 subnet, we will take /32 addresses from there, and then we will configure it on the gateway. So it makes your configuration a little bit simpler. You can just plug in your branch gateway, and then it'll grab a system IP address, and you don't have to really worry about it. The second way that you can do this is by designating a VLAN. So in this case, it would be the management VLAN as the system IP for the gateway. And you can do that by just selecting the VLAN once it has an IP address and then saying, hey, I want this to be the system IP address. Doing it this way with a system IP gateway pool is simpler on the admin. The one caveat to this is you only want to use this in a non-redundant branch scenario or if you're doing some type of routing, and we'll talk about that later. But when we get into our redundant branch scenarios, you don't really want to use this, and I'll talk about why you don't want to do that when we get there. So that's the system IP address. That's why it's important. Another important thing about the system IP address is we actually proxy. So for Radius requests, like our AP down here, if we send out a Radius request or we get a client that gets onboarded, we send it to the captive portal, for example, we are going to proxy that request via the gateway over to the Radius server. What that means is the system IP address is going to be used as a source. So we're going to want to make sure that the source IP or the system IP address of the gateway is allowed on the Radius server as well, so that all the connectivity will work out. The next thing I want to talk about is clustering. So let me clean up this screen a little bit more here. First and foremost, what is clustering? Clustering is a redundancy mechanism that we have on gateways, and this can be campus gateways and branch gateways. For branch gateways, the caveat is that we only allow you to have a cluster of 2 at a branch site. At this branch site, we could have a second gateway, but we can't have a third, for example. But that doesn't stop you from having more than one gateway at your hub site over here. So you could have 3, 4, etc. But in the branch, you can only have 2. So that's one caveat. There are 2 ways that you can actually do the clustering mechanism. By default, we use site clustering, but you can also do something called group-based clustering. Not recommended in the branch context, but you may see that term auto group clustering in the wireless context, which is generally in the campus, for example. Just so you're aware that that's a possibility, but it doesn't relate to branch. By default in branch, we use site clustering, which means a couple of things. You need to ensure that your gateway, so this gateway, these switches, your APs are all in the same site, because it makes your topology appear, but it also puts the gateway into the cluster. And even in a non-redundant site like this one here, this single gateway will be a cluster of 1. You want to make sure that this has a site that it's applied to. From there, you'll have your gateway in a cluster of 1, and your site will be up and running and good to go. That's our first scenario. Let's move on to our next scenario. Here's our next scenario. It's a redundant branch with 2 gateways. And you can see it's the same type of setup. So we have 3 VLANs here, management, 2 user subnets. We have some switches down here, and then we have our AP. And then we also have that management VLAN trunk to our AP. And then here, these are actually connected. So these 2 gateways can reach each other and speak to each other as well. And then we have our system IP address. And then we're also going to be speaking about clustering and a couple of other nuances that are specific to a redundant branch. The first thing is the system IP address. It differs from our non-redundant scenario because we're not going to be using that system gateway IP pool. And the reason for that is because we have a active cluster. We actually have a peer we want to reach, and that peer needs to reach us as well. And that system IP address is what's going to be used as the source and destination for the cluster keep alives. And if we were to use that system gateway IP pool, it's going to give us a /32 address, and that /32 address is not going to be reachable across our LAN here. So we would have to do something like enable routing in order to get that learned over from one side to another side, and that makes things a little bit messy, and we don't really want to do that. What we should do in this scenario is designate our management VLAN as our system IP. And then that way, the VLAN is already going through both gateways and down to the switches. So now it'll be reachable across the LAN versus us needing to complicate the network deployment in order to ensure that clustering is working. That's the first nuance that's different in this scenario versus what we had before. And I don't want to erase that line that we had before, but I might just clear it up and draw it again. The clustering is also going to be a little bit different as well, because we actually have a cluster peer, which is this guy. We're going to want to designate one of these devices as a cluster leader, and I'm going to explain why that's important in a second. Let's talk about another aspect that's used in this deployment, which is VRRP. Now, we don't actually leverage VRRP for the redundancy mechanism. We have clustering for that, which is significantly faster in terms of failover versus VRRP. But we do leverage VRRP's virtual IP address. So that VIT we do leverage, and that virtual IP address is what the cluster leader is going to be in charge of. And the cluster leader also needs something called default gateway mode. And default gateway mode is enabled by default, so you don't have to turn it on or check the box or anything. What it does is it basically says whoever owns this virtual IP address is going to be the person that owns the routing for the branch. So this gateway is going to be in charge of sending traffic to the radius server, like getting traffic out, all that kind of stuff. So it's going to be in charge of that. And it's also going to source it using that virtual IP address. Hey, Editor Clarence here. I noticed in this part of the video, I was speaking about the virtual IP address and where it's sourced, and it might be a little bit confusing in this portion of the video because we were talking about the system IP address before, and all your traffic will be sourced from that system IP address. And now I'm saying that the virtual IP address is where all the traffic will be sourced from. And I want to make a point of clarification here. The virtual IP address will only be the source IP address for radius and change of authorization, or COA. It won't be the source for other types of traffic, like DNS, for example. So I just wanted to make that clarification, and back to the video. Reason that's important is in case this device goes down, for example, that virtual IP address is still reachable. So we can actually get the traffic back across this other device and still have our connectivity be good. And that also means that if this device goes down, this guy will take over as the probes start to die out. So that's why the cluster leader is important, because it actually is in charge of that virtual IP address, and it helps us minimize issues if things go down. Additionally, our devices are also going to use our cluster leader to tunnel all the traffic to it and send all the traffic to that cluster leader. It's really important because if we didn't have that default gateway mode set, what could happen is we load balance basically, where we're sending traffic here, and then we're sending traffic here, and then we get non-predictive paths. So some of the traffic will go out one link, if we have our uplinks up here, and then it'll return here, and then this guy won't have the state of what traffic was going through. So it gets really, really messy. And what the cluster leader basically does is ensure that all the traffic flows very nicely out one way and then comes back the same way and then gets routed out to the destination. Now that doesn't mean, let's clean this up a little bit here. Now that doesn't mean that this device is uplink. So if it had a WAN uplink up here and this guy has his WAN uplink, that doesn't mean that this WAN uplink won't ever be used. We can actually take advantage of something called WAN sharing, and there's more details on how you configure this and what you need to consider in the VSG. But just to briefly touch on it, WAN sharing will allow you to share this uplink across to this other gateway, and this gateway's uplink across to this gateway. And now, when all that routing decisions are being made, this gateway has the option to send it out the LAN and up and out to this other uplink. So you're not just utilizing this guy's uplink, you actually have the ability to send it out this way. And then because of that, we'll actually be able to send the traffic correctly back to the devices. So that's one important thing to note with this. It's slightly different because you have that cluster leader in default gateway mode, and you want to ensure that your traffic is routing correctly and everything is going out the correct way. One other thing I want to briefly touch on is grouping. So in the previous scenario, we didn't really talk about grouping or anything along those lines, but in this scenario, I want to talk about it because now we have two different kind of deployment types. So I think it's important to talk about what the grouping should look like. Now, if you have a redundant branch site like this, for example, and then you have a non-redundant branch site, which is the previous scenario up there somewhere, you probably want those two branch sites to be in different groups because you want like configuration to be with like configuration with Aruba Central. So in this scenario, because we have redundant gateways, probably want that to be in its own group. And in the previous scenario, we didn't have redundant gateways, so you probably want that in a different group. You do want both of those groups to include your gateways, your switches, and your APs. And then within that group, you want your switches to be a template, your APs will be a UI group, and then these will also be a UI group. And the reason you want your switches to be in a template group is it's pretty simple to just spit out a generic configuration for your switches and have that be cookie cutter. And it's really, really simple. If you use a UI group, you have to do some manual work for each of the switches. And you probably don't want to do that when you're deploying a bunch of branches, right? I'm thinking of, some type of retail store or something where they're building multiple stores at a time, et cetera, et cetera. They're doing, a deployment of like, maybe there's 20, 30 stores going out and they just want to spit them out, have those kind of scenarios going on. They don't want to do too much work of going back and adding and checking a couple of things on the UI. So that's why we would use a template group for switches. And then UI group for APs and gateways is what you should use. And then they should all be within the same group. So I just wanted to touch on that briefly. We're going to move on to our next scenario. Moving on to our SD-LAN deployment. This is a redundant site. We have that same physical topology of the redundant branch that's above. I just don't have the actual lines drawn, so I don't have the connectivity drawn to my switches and my APs over here, et cetera, et cetera. The first thing I want to talk about is what's going on in this topology. We have some clients down here, we have our switches here, and then we have our APs here, and then we have our gateways. In an SD-LAN scenario, your clients are going to be connected to your switches, and then or connected to your APs, and then they're going to tunnel you to a branch gateway. The reason that I said a branch gateway and not both branch gateways, which this diagram kind of looks like they're tunneling to both branch gateways, but in reality, it's just one, is because that cluster leader that we spoke about is going to be in charge of terminating all of your tunnels. Also going to be in charge of doing your enforcement. So you get to leverage all the IPS, IDS, roles, all those good features within the branch gateway directly. So your clients go directly to the gateway, and then you take advantage of those. So you can do things like microsegmentation. You can have certain devices within one role not speak to another role, instead of it needing to do things like a IP-based ACL, for example. And IPS IDS is going to be on regardless. Well, you have to turn it on for one, but it'll be on and you can leverage that whether you're in an SD-LAN scenario or not. The main thing that this gives you the advantage of is being able to have that role-to-role policy, which simplifies how you define policy. Additionally, it simplifies your network. So you no longer need the VLANs assigned on these interfaces here or specific VLANs for anything on that switch. You can just have it be, management VLAN for your APs, and then you don't have to worry about any of the VLANs for your clients or anything like that. So it makes it simpler in that aspect. The one thing you do need to be aware of is, let me clean this up a little bit, is that, let's draw this connection again. Thing you need to be aware of is we're still leveraging VRRP between these two devices. So we want this link here to have whatever VLANs. So before we had like VLAN A and B, we're going to want those two VLANs to exist on these uplinks so that these two devices can communicate with each other and do the keep alive for that VRRP between the switch as well. Clean this up one more time. And let's talk about the failure scenario. So I just said that, hey, if we're going to be tunneling everything over to a single gateway, and we're also going to have some redundancy mechanisms that go through and make sure that the VLANs are alive and they can reach each other. Also for clustering, you're still going to want that management VLAN to be between these two devices. Be aware of that as well. But if this gateway goes down for whatever reason, he's out of here, all your tunnels will then fail over to this other gateway. And whenever you're doing any of the tunneling mechanisms, so for UBT or the APs, they're tunneling, we always build a primary tunnel and a backup tunnel. So if this tunnel goes down, it immediately will switch over to this second gateway, and then it'll take over and be in charge of everything else that we talked about before, like TACACS, AAA, DHCP, and then also tunnel termination, your policy enforcement, all that stuff. That's everything with SD-LAN. There's one more scenario I want to quickly talk about, and that is about the routing or routed branch deployment. So let's jump into that. In our final scenario, which is actually kind of two scenarios, we're going to be speaking about a routed branch deployment, which is this one on the left-hand side, and then a routed branch deployment that's also doing tunneling in this scenario. But first, let's tackle the just routed deployment. So in the routed deployment, there's not much that you need to do. If you're routing between your switch here and some downstream switches, and between your downstream switches to your upstream switches, you're routing to the gateways, you don't need clustering. You just rely on routing. If it fails over, it fails over, And if you're doing ECMP, you'll do ECMP. You just don't really need to do much. You're reliant on the routing protocol at that point. So there's not much that you need to consider or think about in this scenario. So you don't need to do clustering. You don't need to worry about any of that type of redundancy or anything along those lines. Pretty straightforward. Now, if you are in a routed deployment and you are tunneling, in that scenario, you're actually going to need, clean this up a little bit so you can see. In this scenario, you're actually going to need your tunneled subnets to exist between these two gateways on this link here. And you're also going to need a management VLAN as well. And again, that's for your cluster probing and your VLAN probing so that we can tell which gateway is active, which one's not, etc. So you're going to need to identify a cluster leader. And then from there, we're going to need to have that keep alive go across the link. So you're going to need that system IP address to be set again. And then it has to be reachable via management VLAN. And then your user subnets, the tunnel ones, because you're going to be leveraging VRP, needs to be able to go through and pass through this. So you're basically getting L3 here, but you're not really getting L3 up here. You're going to use L2 because we have to have those keep lives between the two gateways. And you can go through the switch to do this. So those are the two things to keep in mind. And if you're doing a non-redundant branch, you don't need to worry about having those VLANs exist here, actually. Let's just pretend for a second here, for simplicity's sake, this is not here, and this link doesn't exist, and you want to tunnel. Well, in that case, you only need your system IP address to be here, and you don't really need a management VLAN down here. You can actually just have that be an L3 interface, because whenever you tunnel, all the VLANs already exist on this gateway, so there's nothing to communicate to another device. So you can actually do that in a non-redundant setup as well, and that's what it would look like. And the same thing would go if you're doing L2 as well. It wouldn't really matter. You're still going to have the same considerations, or the same ideology. So since all the VLANs are going to exist on that single gateway, you don't really need to do anything fancy with this link down here or any keep lives or anything like that. That was the last section. And with that, we're going to conclude this video. We talked about a bunch of stuff in this video. We talked about redundant branch, non-redundant branch, L2, L3, sites, clustering, grouping. But there's one thing I didn't really talk about, and that's which deployment type should you use? Should you use a redundant L3 branch? Should you use a non-redundant branch? Should you use L2 redundant branch? And the reason I didn't really talk about that too much is branch deployments are not a one-size-fits-all. It really depends on what you are looking for as a customer. Now, I'm going to recommend a deployment that's a L2 redundant deployment because it gives you the most resiliency and it gives you that flexibility to be able to tunnel and get to leverage some of the aspects of zero trust. But that doesn't mean it's the right fit for everybody. With that being said, this concludes another VSG expanded video. Thank you for joining. If you want more details on the VSG or any of the topics I talked about, the link is in the description below.